Hi everyone, thanks for joining our webinar today. We'll be getting started. We are excited to discuss stereolithography 3D printing and how it compares to our extensive list of additional additive capabilities. Today our host will be sharing the strengths of SLA and when to choose this process for your project. First, I'd like to introduce myself. I'm Shilpa and I'm on the marketing team at Xometry. A couple quick notes before we get started. Please submit questions throughout the webinar for our presenters to answer at the end. I'll be monitoring the question box on the GoToWebinar panel, so just feel free to submit them at any time and we'll get to them at the end of our session. We'll also send a webinar recording around for anyone who'd like a copy and for you to share around with your colleagues. All right, so first I'd like to introduce our team. Meet Greg Paulson, Director of Applications Engineering at Xometry. Greg brings many years of experience and leadership to our team here at Xometry. He's an expert panelist and speaker on all things additive manufacturing. And if you've seen any of our YouTube videos, he's also the star of our Engineering Challenge series. Before Xometry, he was actually a project engineer for many years doing rapid prototyping. So he brings subject matter expertise as well as manufacturability expertise. Next, I'd like to introduce Tommy Lynch. He brings over a decade of experience in additive manufacturing with hands-on experience in 3D printing with direct experience in SLA, SLS, DMLS, FDM, and urethane casting. For Xometry, he is the head application engineer for anything additive. So he is your go-to for any special requests when it comes to materials, processes, finishes, and production requirements. So thanks again for tuning in. Don't forget to submit your questions on the webinar chat. And with that, I'll pass it over to Greg.
Hey, thanks so much, Shilpa. And Shilpa, we need to put your picture on these title slides.
That third little picture right at the bottom, yeah.
Shilpa's face will visit you if you are on the Xometry homepage and scroll down a little bit. She'll pop up asking you to sign up for our newsletter.
Please sign up for our newsletter.
Please sign up for our newsletter. We are, I'm here with Tommy today, and we are very, very excited to talk about stereolithography and where it fits in the whole scheme of manufacturing, whether you're prototyping parts or moving to some form of end-use production. SLA has played a role historically for, over 30 years now. We're just really, really excited to offer it. So today, I'm going to start off with talking about kind of what's new at Xometry. At Xometry, we're not just adding materials, we're adding features, we're adding other things that make your life easier when you're trying to procure custom manufactured parts. We're then going to talk much more in depth into the SLA process, where it lies in the manufacturing continuum, some of our materials that we have, and then we're going to leave a lot of time open for question and answers, where if you have an application-specific question, or if there's a material that you use or some past experience that you have with SLA that you want clarification on, this is where we really want you to ask those questions and we can answer. Tommy has had experience not only with using these parts, but running the machines, operating, cleaning. Like, he knows the pain of SLA, he knows and the power of it as well. And my experience has been making parts using SLA. So I've been using it for applied engineering, rapid prototyping. So together we have, we have a couple of decades worth of, cutting our hands on the product, so we could talk much more in depth about it. And then of course, just going over some of our Xometry online resources. So let's talk about Xometry and where we are right now. I think every single time we run a webinar, we've had one or two more things that are happening live on our website. So I'm actually going to toggle there and talk about what's new. So a few things that happened, lots of exciting things, and you may see that our website looks a little bit new, refreshed. This came along with a merger that we had with MakeTime, where we were actually able to get some fantastic talent on board, as well as we built up a manufacturing network of even larger amounts. I think we added like 1,300 extra manufacturers to our manufacturing partner network. So now, we, with our combined forces, we are the manufacturing on-demand platform where you can click with your 3D CAD file, get an instant quote on many manufacturing technologies, and just make it as simple as e-commerce can be. For those of you who are not familiar with Xometry's platform, I'm going to go over our instant quoting site in just a little bit here, but we are utilizing not just our internal capabilities for fulfillment, but also a manufacturing partner network of, as I mentioned, about over 2,000 manufacturing partners to make parts to spec and on time. we're not just prototyping here, we're able to scale up to full spec manufacturing, whether it's specific features, surface finishes, tighter tolerances, we're able to hit those. And the choices that we have are massive. So we go everywhere along the, along the lines of plastic 3D printing, metal 3D printing, to more traditional process like CNC machining, sheet metal fabrication, injection molding. And we even have a bridge technology where you could take essentially the ideas of plastic 3D printing and turn into end-use parts using urethane casting. The other thing I wanted to show with our new navigation is we have a lot of resources that we're now making much more transparent on our site. So I really recommend checking out our design guides if you are not familiar with one of our processes here. The production guide is a great place to start out. It's basically a 2-pager per process that we offer, so you kind of get the strengths and trade-offs at a glance. If you would want to dig deeper into any one of our processes, please download our individual design guides. You're going to get a better understanding of what that process is, what the strengths are, how to optimize your design for that process, and really where it lies in this whole manufacturing continuum. We got a lot of guides here. I would also recommend checking out our FAQ, which is on our site here, and it's basically any question that we see ourselves answering a few times a day. We've created an article around that. So whether it is a question about a tolerance or a feature, or whether it's a question about something like I want to get set up on purchase orderings or net terms, we have those answers that are on our FAQ. The other thing you may notice on our site is we always have help available. So if you are looking for a quick answer, like let's say, I'm interested in surface finish, I could quickly look at our FAQ here. If I want to talk to a representative, I could even click live chat down here, and we have live chat from 8 a.m. to 9 p.m. To answer any of your manufacturing needs. So a lot of resources. All these things are pointing towards let's make parts. So how do we get to going with that? It starts with the get a quote experience. And in this case, since I'm doing a demo, I'm actually I'll take a part that I've recently uploaded here. So if I go and log in and make an account, all the parts that I've uploaded are actually saved to my account, so I don't need to upload them again and again and again if I'm quoting multiple times over or multiple processes. And you can see here a few things have changed. So we have, for example, our DFM warning is much more transparent at the top. We're now showing like, hey, in this process, we have a thin wall. You may also notice that, again, my pricing that came up there, like instant, and I'm getting this instant pricing, but say I want to change my materials, I could click anywhere along this area here, including modify part, to bring me to a place where I get into the specifics about selecting my materials and process. So we offer a lot here: 3D printing processes, CNC machining, sheet metal, urethane casting. In this case, I'm going to highlight SLA for obvious reasons, because that's what we're talking about today. We have a performs-like dropdown that can help you out if you're looking for something to simulate a material, because everything in SLA is an engineered simulant, so something that acts like polycarbonate or polypropylene or ABS. Let's go with ABS here. I could drop that down, and I could select materials that act like ABS. So let's do extreme white. And let's do this in high resolution. You'll see a few things happen. Your price updates, as well as DFM feedback, will show on the site. So in this case, I have a very thin area right here that I may want to address. So let me go ahead, save properties, and show the next cool feature here, which is our replace file. So this is brand new. This has been requested, I don't know, for probably like a year and a half right now. So we're really, really excited to add this on board. But now that when you get this DFM feedback, you can upload a revision right on your website or right on the site, so you don't need to go into our parts library anymore to upload your replacement file and basically change your rev. You can do that directly on the site. And once this uploads, this version I had here, I essentially took that DFM feedback, I did a design modification on my part, and boom, there's everything is green and golden here. So my feature down at the bottom here, I added more beef, I cleaned it up, and now I should be fairly confident with my print that everything's going to turn out just great with this feature. With SLA in particular, we have a few finishing options. We'll go about further here, but we have standard, matte, and custom available. SLA is kind of unique where we have a material called polygel, which is also a photopolymer process. But in this case, I can actually do some stuff like threads, tapped holes, and inserts with this material. It's a little bit more robust. And even things if you need bag and tag, you can click through there. As with all our orders, we are able to add certifications, so things like COCs, material certs. Even if you are working with something export controlled, you can click ITAR here, and that will change. That's extremely important to know up front as we're working this job through. And once you're ready, you could upload multiple parts, configure them how you want. You could just go ahead, place order, and walk through your process. So I could go back to the quote a little bit later if we have any questions in the Q&A session, but I really didn't want to show that replace part feature because it's been so powerful once we added it. It's been widely used, and showing all these options that we have available for getting quotes in different materials and different subsets, for example, of 3D printing. So let's go back here. So let's get into the beef of this. Tommy, what is stereolithography 3D printing?
Yes. Thanks, Greg.
Hey, this is Tommy.
Hey, it's me. It's me. So, yeah, just a little bit of background. I think Shilpa had touched on it, where I've been in the 3D printing industry since, I guess it's been since about 2004, and the first job that I had out of college was actually working in an SLA shop in the finishing lab. So, yeah, I felt all the pain of every part of the process, and this process is definitely very near and dear to me. So as far as what is stereolithography, it's a technology where you're using an epoxy-based photopolymer. Basically, all of the SLA materials are epoxy-based, and by photopolymer, that means that the epoxy is activated or cured by the introduction of UV light. So on the image on the right, you can see this laser scanning, and that's basically what's happening. If you're building a model of a person, then what's going to happen is our software is going to slice that person up into 1,000 layers vertically. With SLA, you have the option of 2,000ths or 4,000ths thick layers in most cases. And there's going to be a build platform that sits just below the surface of that liquid, and it's going to image the soles of your shoes. And then the build platform will drop down by 4,000ths of an inch, and all of the actual building of the part takes place on the surface, and then the part just goes down into the vat. So, some strengths of this process are, since it is imaged out of a vat of liquid, that's kind of the surface finish that it retains. So I'd say that it has a superior surface finish compared to other 3D printing processes in general. It's not going to be glass smooth. You will see the characteristic stair stepping that comes along with any 3D printed process, but considering that your up-facing surfaces are going to be as nice and smooth as the top surface of that liquid, the stair stepping will introduce some roughness, but comparatively it's really nice. As I mentioned, there's a high resolution offering where we can build down to 2,000ths thick layers, and that's going to be in the Z direction, and then the laser beam that it's scanning with is typically going to be somewhere around 6,000ths of an inch diameter for high res, and maybe we'll say 15 or 16,000ths of an inch for the standard resolution. So you're basically have a feature resolution down below 0.5 millimeter easily in the XY direction. This is going to make it highly accurate to your CAD model. The tolerances on this process, I'd say generically, We're starting out at about plus or minus 0.004 inch on any feature, and add an additional 1 to 2 thousandths of an inch, depending on the material. But in certain cases, we could definitely potentially look at going tighter than that.
Yeah, and in my experience, by the way, I've used and getting a little ahead of ourselves, but I've used SLS a lot for functional work. But when I was right about to move to a tool or mold and just wanted to see exactly how it fits, you know, if I had something else assembled or off the shelf, I would do SLA as my final sanity check before I moved to anything in that was hard tooled, because it was very quick to do it, very accurate. And to that surface finish standpoint, I also will say lip seals and things like that work really well with SLA.
That's right. And yeah, and we are going to go into a little bit deeper detail on the surface finish a little bit later on. But yeah, as far as prototyping for injection molding, this is hands down the technology that I've used the most. You know, as and there were a couple of final I guess comments on the SLA process in general. You know, as mentioned before, all materials are epoxy based, so they're formulated to mimic common thermoplastics, and that'll be in terms of relative stiffness, but not necessarily overall durability. But all in all, I'd say this is one of the strongest processes for prototyping in general.
Yeah. So
go ahead.
And Tommy, we have this slide here to kind of show like where does it lie. So one of the things we've been offering SLS, FDM, DMLS, and PolyJet for quite some time now, and I know a lot of our Xometry customers are very used to these selections, kind of where they are. And we're throwing SLA in the mix, which is in some ways is kind of a about time experience, right? Like, why didn't we have it before? But in other ways, it's something new. It's like, all right, when do I choose here? So can you help kind of walk through why I would talk about SLA, why I would choose SLA over SLS at certain points, or when it makes sense over PolyJet, which may be similar because they're both photopolymers?
Yeah, definitely. So, you know, just a quick recap on stereolithography. I mean, the strengths are it has the smooth surface finish, it has the high accuracy and detail, it does a good job of representing common thermoplastics, and overall it's just an excellent balance of form, fit, and function. The one drawback with this technology, and this would also apply to PolyJet, is that it will have a limited lifespan. Since it is an epoxy-based photopolymer, if you put it, let's say, outside in the sun, since UV light is what's used to cure the epoxy, it continues activating, and so your parts will darken with exposure to UV and ultimately become more brittle. Also, when exposed to moisture, these materials will have some tendency to absorb humidity out of the atmosphere, or, you know, absorb some moisture in the fluidic applications. Don't take that as you shouldn't use it for fluidic applications, because that's one of the top uses of the transparent materials, but I'd say just don't plan on using it for months.
That makes sense.
So, you know, when looking at when to use stereolithography compared to selective laser sintering, you know, in my mind, I'm kind of thinking like a drill housing. You know, for a normal hand drill, you know, you're going to have two halves that have relatively complex exterior surfaces, and they're going to have a bunch of bosses and stuff on the inside. I'd say for the general fit and holding it in your hand, stereolithography is the way to go, because it's a very stable process. You're not going to have to worry about any warping or anything. But with selective laser sintering, where that would, when I would say it's time to use SLS, is when you really have to do some sort of functional testing with that drill. And, you know, I've seen cases where you can take SLS parts and, you know, hit them with a hammer, and they won't break. Whereas with an SLA, if you drop it from, you know, a 3-foot tabletop onto a hard floor, there's a chance it may shatter, and especially with the stiffer materials. So
Yeah.
I'd
And
say when you need more strength is definitely one of the qualifying criteria. And what was that, Greg?
I was gonna say, yeah. So if I'm doing something where I'm designing, for example, I'm doing this drill set. I'm taking the halves together. I'm using it. I'm building it for, say, a trade show or a model demonstration of it. And again, I'm gonna say final fit check probably way too many times during this webinar here. You know, I'd be choosing SLA. But if I have a separate test here where it's less about kind of the cosmetic aspect of it, and it's okay for me to kind of drill or glue or do something just to get a functional test out there where maybe in the field for several months, make sure someone doesn't get some, you know, a hand fatigue or something based off design, I may choose another process because of the long-term lifespan of that. Yeah.
That's right.
Yeah.
And you know, another application where selective laser centering definitely has its strengths is like large hollow parts. And you know, one of the downsides is that you're not going to have any transparent materials. I'm not really talking about water jugs necessarily, but you know, with SLA, since it is built in a vat of liquid, it does require you know, support structures to catch any we'll say freestanding features. And again, you know, just kind of going back to building the model of a person, the specific example would be if you're stacking them layer on top of layer, where you image the soles of the shoes, you build the ankles, you build the knees. Well, the fingertips are going to require support structures when they start growing, or else they're going to float off into that vat of liquid. With SLS, that's not the case. Since everything is encased in basically a powder cake, there's no need to secure the parts because they're secured by the surrounding powder. So yeah, in the case of tanks or, you know, something that just has a big hollow inside, with SLA, it may be difficult to remove support material from the inside of the part, but with SLS, you can do it all day long and just dump out the excess material, and that's really nice strength of that technology.
Yeah, and I've seen, like, if I had a need for something that does have a translucent look, with SLA, you could often do a split and bond with, say, an epoxy.
That's right.
Yep. You know, something, I'm skipping over to PolyJet real quick, but I know I've used PolyJet extensively in stereolithography in the past. Sometimes their roles overlap with each other because they both are a UV cured system.
Yep.
You know, my experience is I found that SLA tends to have a better hand feel. And it sounds kind of strange, but if I'm working, you know, with a product, I'm developing a product here, SLA has more of it just feels like plastic. Oftentimes it looks like the injection molded plastic part that you're making.
Right.
And PolyJet tends to have this very, very slight film to it that has to do with how the support structure is generated. So SLA, the support structure, is actually the material itself. So it has tiny little, almost toothpick-like tines kind of holding the part up as it's growing, as Tommy described. PolyJet, you're using a gel-like support structure. So a couple things happen. That gel-like support structure it has that little residual layer to it that you'll get on the part, but also because of how you have to remove that support structure, oftentimes you can destroy small detailed features. So I really want to highlight SLA is the first option that we have at Xometry, where you can actually you not only have like something that just naturally has good resolution, we have even a higher resolution option out of all our 3D printing materials, where you could actually, for many of these processes, select a high resolution. But if you do have things like text or smaller detailed features, they tend to be more survivable with SLA than PolyJet due to how you can remove the support. There's a few asterisks to that based on how the overall part and how it needs to be oriented, but as a general rule, that's something that I've kind of lived in when I've done this. PJ's got multi-material and rubber too, so that's something cool.
Right. And, to kind of expand on that, I mean, in my experience, if you can use SLA when compared to PolyJet, I typically default to SLA every time. As far as the overall feature resolution, I think SLA may have an edge in terms of the XY definition, but keep in mind that PolyJet actually has a smaller layer thickness. Um, and so it has a nice surface finish as well, but I just feel like there's a little more versatility when using SLA, just because if nothing else, the post-processing requirements, and just to kind of highlight it for everyone out there, when you're processing SLA parts, you're building it in that vat of liquid, and then the whole build platform raises up out of there. So the only thing that's attached to your part is the lattice work of support structures, and then just a thin film of liquid material that just stuck to the surface. So all you have to do to clean those parts is basically dip them into a bath of solvent, and it dissolves away the liquid portion, and then you can pick away the support structures. And this, when it comes to small details, I think this is the big advantage. You can take extra care, whether you're using like an X-Acto knife or a little dental pick or whatever it is, to make sure that you don't break your small features, even if they're down-facing features. And then ultimately it goes through a UV light oven, and now you have a part that's ready for some light sanding. The PolyJet process, even though it can resolve basically to the same amount of detail, I think one of the sticking points from the post-processing side is that, number one, to remove the dissolvable support structure, you basically have to use a mini pressure washer, and that's not going to be as accurate or as intricate as you can be with the tip of an X-Acto knife. And then the other thing is there may be a little bit of a film left on the bottom of the parts that's ultimately going to have to be scraped away with like a dental pick or something. So, in that aspect, both machines make excellent parts, but I feel like you just have a little bit more flexibility with stereolithography pieces, and especially on smaller parts.
Yeah.
And ultimately, when we start getting into larger parts, the SLA build platforms get larger than the PolyJet as well.
I thought that was really interesting, and I'm going to say something that's going to make Tommy cringe a little bit, but there is access right now, SLA platforms up to 58 inches, including those within our manufacturing partner network. We're actually, I think through our partners, there's over 100 industrial SLA machines available, and that's one of the reasons why we're able to offer so many materials. So we'll go into that further, but we're offering now 15 materials for SLA, which is one of the widest selections you'll find in any single place. But that being said, when you get that big with a SLA print, there are other things that go, like other environmental things, like the curing of the material, the actual, like, the post-cure process, things that can actually add to potential warping or damage to the part, and you're also adding, like, it's very, very high value print at that point. I think we recommend parts to be under about 20 inches. If you're over that, that's something we can definitely do, but we want to take a look at it. But that I may start leaning you towards things like fused deposition modeling when I start talking about these like larger panels and things like that.
Right. And yeah, I mean, definitely there are some monster SLA machines out there, and I'd say that I've had a good bit of experience on the iPro class machines, like the iPro 9000s. That's going to be a 29 by 25 by 21 inch build platform, and they definitely make good parts. But as Greg mentioned, once you start getting over the 20-inch range, we get back into the concerns about overall durability. Are you ready to pay, $5,000 or $10,000 for a piece that may just break if you drop it on the table? Or the environmental concerns of if it's going to be sitting in a warehouse or something, then, you know, it may have a tendency to warp. So in most cases, I will say, as we start getting into larger pieces, FDM or fused deposition modeling is actually a really nice process, because it just does well with larger parts like flat panels, thicker pieces. You have the infill options, and you're going to sacrifice somewhat on the feature resolution, because now we're looking at building in 10 to 13 thousandths thick layers as opposed to 4. But, you know, number one, it's going to be lower cost than the SLA counterpart, and you know, number two, it's going to be made from a real thermoplastic that's not going to have all the limitations of you know, the epoxy based photopolymer materials. So, you know, it's as Greg said, there's big machines out there, but 9 times out of 10, I just feel like as we get into those larger applications, FDM wins out, because there's very few large parts that are really going to need to have, you know, significant accuracy down below 1 millimeter on specific features. That, yeah.
Yeah, and personally, those large machines, for me, I see them more as, I want to build a small part 1,000 times in one run. And that's really where those large platforms come in. So I wanted to say that and get it out and clear, because we do have these large platforms. But again, usually once you go over that 20-inch mark, there's going to be you're going to start putting in risk. And that's something, by the way, for SLS, for PolyJet, for direct metal laser sintering, you run into, is when you start designing your part to the maximum of the build area, you start to actually design in risk to that part, just because of natural little things that can happen during the 3D printing process. I just wanted to touch base on direct metal laser sintering. I mean, it's very different as far as the process and material goes, but some ways, like, it's very similar to stereolithography, because you are building parts off a build base. In this case, direct metal laser sintering, you're building with a metal powder bed. But you're doing a similar thing where you're building these, you know, small protrusions that are supporting the part with this metal support structure. The difference is you're not using an X-Acto knife usually. When you're moving, you're using a bandsaw and pliers and CNC machinery. So the finishing side of DMLS is very, very different. Even though conceptually how the parts grow is very similar, and just has everything to do with the materials that you're building with. And I may use, for example, SLS or SLA to do a test run of something that I may build in direct metal laser sintering, because the the cost is going to be much, much less to prototype something before I commit to something like DMLS. Especially as I get to larger and larger parts that are like over the size of my fist, I may want to spend more time on the prototype to ensure that it works before I move into a full metal part going through. I wanted to go down our material offerings, and something on our site is, if you do go to our FAQ, there is a link for learn more about our materials. And at that point, you could actually scroll down, read a small description of each one of these materials, as well as download the data sheet for these. The data sheet will also be available on our website as well. When you select that material on the quote dropdown, you'll be able to see that data sheet. But yeah, we've partnered with these manufacturing partners all across the United States that are running, you know, real professional stereolithography. One of the coolest things that I think we've been able to do is we've been able to offer both Acura and Somos material selection. So Acura and Somos are actually competing brands, but Xometry, we're not a single unit. We're kind of agnostic. All we want to do is focus on the applications that make your project a success. So you can click, drag, upload, and quote in these 15 materials, some of which have high resolution. Again, to help out a little bit, since people don't know the difference between Acura 25 and Acura 60, for example, or Acura 48, like, what do those numbers mean? I don't really know, but I can tell you that they're made to simulate things like polypropylene or polycarbonate. And so we've actually created these major level categories for saying, hey, I have a polypropylene-like, or I have an ABS-like part, or a polycarbonate-like part, or even a rigid ceramic. and I'm able to, and it'll help you actually down select from these 15 parts. And as always, you could go even further with our data sheets, or even chat with us or talk with Tommy to help select through. But you'll see some themes going through here. From a general purpose standpoint, a lot of times our customers look at Somos Next or these Acura Extreme materials as your, okay, this is my kind of my catch-all material. I don't know quite what to choose, but I know these ones will work for my goal, because it has a very good balance of flex. So things like snap tabs, things like lip seals tend to work pretty well with this material, as well as a little bit of durability, because that flex gives it what I would consider impact resistance. Another way to be durable is to be, sturdy and strong. So things like Acura 60 is more kind of polycarbonate-like, and it's stiffer, but that means when it breaks, it doesn't bend, it snaps on you. And then Tommy, actually,
Yep.
you have more experience on this, but things like bluestone, and Perform are ceramic filled, and which don't even expect it to bend, right?
Right, yeah, those are not going to bend at all, and yeah, they're ceramic filled materials. So I just hesitate to even refer to them as plastics. But yeah, they're very stiff, very rigid. They may chip a little bit, but I'd say overall, when you're thinking about these material selections, I'd say that the polypropylene like is going to be the most flexible. ABS like is going to be the next up in terms of slightly more rigid. I think there's a lot of good options for general purpose materials in here, and while we have a good list of multiple materials that fit within each of these classes, I'd say the main differentiators are pretty much going to be color. Outside of that, I mean, the extremes were made for impact resistance, but otherwise, you really can't go wrong with any of these materials. It's just a matter of, do you want a transparent part? Do you want a black part? Do you want an opaque white part?
Yeah, and Acura ABS Black is actually, it's a very high demand part, because it is this really nice clean black. It looks like an injection molded black part. And it's something a lot of our customers lean to. There's something, this is actually newer to me, but Somos Taurus has been getting more popular because it's a darker gray color, which is a great prototyping color, but it also has very nice performance properties. And I've been impressed overall with that material that I've seen. And I just want to highlight Somos Prototherm is probably one of the coolest SLA material colors that I've seen. It's useful. It's a useful material too. You can post thermal heat treat it, and you get high temperature resistance. But I mean, it's on fire.
Yeah, that's actually a good point, Greg. There are a few of these materials in the polycarbonate and the ceramic filled options that can receive a thermal post cure to increase their temperature resistance, and that would be the Acura 48 HTR. The Prototherm 12120, and then I believe it's going to be just the Bluestone and the Perform. Yep.
And that'll be temperature resistance wise, I believe after post thermal heat treat, it goes from about a heat deflection of 57 Celsius to somewhere around like 110 Celsius. So yeah, again, compared to like true thermoplastics, it's still actually fairly low in the game, but it's something that can bring a higher performance level. At this point, that'll be more of a custom quote, but we hope to automate that within the quoting process. I also wanted to spend some brief amount of time on what does SLA lead to. So we've compared it against other 3D printing processes and talking about how it goes, goes hand in hand, and where to choose SLA. Usually, again, surface finish resolution. That's one of the biggest things that is talked about when you talk SLA. But SLA also has played a very, very important role in our role with this top row here. So when you do something like bridge tooling, and I'm building urethane casts, one of the first things I do is I create something called a master pattern. And that is something that is very accurate to CAD. I'm usually going to do some sort of hand finishing to it. So for example, dry and wet sanding to get it to a smoother surface finish. I may even do things like clear coating to bring up a more of a gloss look to it. But with urethane casting, you're actually making a silicone tool around that master pattern. So whatever that pattern has on it is going to be what shows up. In fact, I've seen examples of someone accidentally puts a thumbprint on that clear coat, and all of a sudden every single part has a thumbprint in it. So getting that detail right from that pattern is really important, and SLA is almost always the pattern used. I mean, very rarely is it something like Polyjet, and again, that has to do with some surface finishes and things like that, but you will almost always see SLA hand in hand with someone who does urethane casting, like we do over here at Xometry. May even get SLA parts before you actually start casting, again, for that check, and just make sure that everything fits together. And I actually like having SLA parts, especially if you have parts that made together with those casters, so they understand the function that you're trying to achieve with your cast parts. Those high temp materials like Tommy offered tend to work really well because when you do cure the silicone to make your mold, it's usually in a temperature chamber. So that helps avoid deflection. The smaller part is, the less worrisome it is, but usually it's one of those higher temp materials like Accurate 48 or Prototherm. SLA, again, for injection molding, it is the best prototyping method. So if you're moving to an injection mold process, very often SLA will be the best process for you to indicate anything that you may want to change or update within your prototyping design. Especially if you're going beyond kind of prototype molds where you're, if your quantities are like over 250, for example, I highly recommend at least building one or two SLA parts to just check your give yourself some sanity check, because injection mold could be anywhere between like $3,000 $7,000 even for the prototype level, and then of course you're going way up, and we've done molds that are $20, $40, $60,000 depending on the complexity of it. So having that little bit of validation up front is just really important before you sink money into a hard tool. On the bottom here, I have CNC machining and sheet metal fabrication. It's sometimes used. I'm not going to say that it is the most popular to prototype these. I've seen some of the more rigid materials used as fixturing in the past, even stuff like bluestone. But you have to really kind of make more of a chunkier part for SLA for this to work. Where I've seen it used a lot or more often is usually something that has smaller details, again, using a high resolution aspect. So if I have threads, splines, or gears, and I want to test that out before I machine it, because it can be very expensive to machine those features, I may use a SLA model to achieve that, to make sure things function to a limited degree before moving forward with something when I'm milling. And just by the nature that SLA it acts like a plastic, it doesn't have the same rigidity for sheet metal. So I could probably count on one hand the times I've seen SLA used for sheet metal prototypes. I've seen other processes in our 3D world used, but again, with our site and our lead times, often it's almost quick, or maybe 2 business days further just to get the real thing made. So I'd recommend when you're looking at different options for prototyping sheet metal, look at sheet metal as an option as well. Yeah, but just going into this and kind of, and please, folks, get your questions ready. I know we've seen some coming in, which is awesome. SLA, it's easy to sand, it's very versatile, 30+ years old. So a lot of people have tried a lot of stuff with this. So Tommy, we have a couple slides here talking about standard and custom surface finishes.
Yeah, so I guess to start out, as far as what we offer, our standard finish is basically going to be the natural kind of as-built finish with some cleanup on the supported surfaces. And that's just going to mainly be to remove any protruding indications of the support stubble that may not have torn away when they were cleaning the parts. Let's see. So sorry, my screen went blank there for a second. So
Well,
you may see some small, grid-like dots where the support indications were, but overall, that's going to be your most accurate option. We can also do the matte finish, where they basically receive that standard finish, but then they go through a wet or dry grit blast process, just so that they have a nice uniform frosted look. And
and most of these images are that matte finish.
yes.
So if this was standard finish, you'd see a little bit more of a glossy top on it. But I don't, all these images here are just a matte finish part.
Yeah, and for cosmetic applications, I will say that I am a fan of the matte finish. From an accuracy standpoint, it's another process that can potentially erode sharp corners or maybe affect some extreme accuracy on small features. But for cosmetic applications, when you apply the matte finish, there may be small scratches or something on the parts, or just little cosmetic defects, maybe some thumbprints where they had to go through the processing to actually get them clean. And once you do that grit blasting, then everything just has that nice, smooth, uniform look. So, that's definitely a nice way to just kind of dress your parts up and make them a little bit more consistent. And then, finally, we have our custom offering. There's just a ton of things that can be done to SLA parts. Whether it's smoothing out with additional sanding on the non-supported surfaces or cosmetic surfaces, painting, the thermal post cure, and then there's also options for nickel plating, which is pretty common, and especially with the rigid composites. So, to kind of wrap it all up, I think from a transparency standpoint, you can see some images down here of parts that were built in SLA, and then they received, some significant post-finishing that basically took them to real transparency. As built, the transparent materials will still kind of have that marbled look, because the layer lines are going to make it to where you can see colors through the parts, but you can't necessarily read text. But as soon as you say, we need additional smoothing on these surfaces, then dollar signs follow very quickly, just because it's a very manual post-processing step where there's somebody in a finishing lab somewhere that's just starting out with probably a 220 or 320 grit sandpaper, sanding it up to about a 600 grit, removing all the scratches in between, and then adding some level of clear coat.
Yeah, and there's also there's a big difference in labor between I want something that looks kind of like an icicle, where it looks glossy, but it's still you still don't see a clear picture through it, like it may have some distortion to it, versus I want something like this faceplate here, where it has been basically optically smoothed out. That is probably 4 or 5 more levels of sanding, wet sanding through, and then several coats to get this type of finish. So just understand that is labor. You can't condense the hours. So that rate expands very, very quickly when you start going from, I want it clear enough. So say it's a name badge and you just want to see something that is right up against it. You could probably get away with just a couple sanding steps and clear coating. To I want to wear these safety glasses and see something 50 feet away. That's a very, very different process.
Yeah. And I'll also mention that we just rolled out this offering. What's it been? 2 weeks ago, Greg?
Yeah.
So right now we're definitely focused on establishing our core, which is building the parts, and we're going to be very limited on anything that we would offer in the custom realm at this point. But it's definitely on the roadmap for something that we're going to have to do. So
in the short term, though, I will say that we're going to be limited on anything custom that we would offer. But one very common conversation that I have with customers is looking at this face mask on the bottom left. It wouldn't surprise me if that was, we'll say, a $300, $200 or $300 part with a $400 finishing job on it. And a lot of times when the customers hear that, it's like, oh wow, I don't want to pay that much. So with ways that you can improve the transparency on your own is basically you get the part as a natural finish, and if you do have a little bit of 400 or 600 grit sandpaper laying around and a can of like rattle can acrylic or lacquer that you can just get from a hardware store, you can do some significant improvements on the parts just by adding clear coat to them without all of the custom finishing.
Yeah. Hey, so I know we're running a little bit here, so I wanted to just make sure we're getting questions ready, and I'm going to go over a few things, but let's spend this next 10 minutes working through some of these questions, because I'm kind of excited. I've been seeing a lot coming in, so anything that we don't get to, we'll definitely catch you offline here and respond as well. Just something, again, we have all these resources. These resources are honestly, they're written by us, like we've with our experiences in mind, and we're constantly trying to keep them updated. So please check out some of our design guides, check out our case studies. We have some really, really cool customers. The exciting thing is 99.5% of the time, we can't share what our customers do, but every now and then we have a customer that says, I've been using this turbocharger in my car that was made out of SLS for 2 years. And we're like, wow, that's awesome. Can we write about it? So if you have one of those stories, please talk to Shilpa. She'll be your best friend on that. And of course, we have our YouTube series. So we have a couple, we have instructional videos, but we also have this kind of edutainment series that I've been doing with different things like heat resistance, impact resistance. And I'm really excited to have 15 SLA materials now on this list, because that really expands what we're going to be able to do with our next set of videos. But to remind you, we do a lot of everything. And there's not one single process that is your answer, right? There's a lot of different factors that go into what you're looking for, whether it's time, scope, or cost, or something else. We're really here to help you help guide your project, because all we really want is a successful project, because we know that's what makes you a customer that'll come back for life. And we're always looking to add to our applications, add to different material selections that we have. So please keep your feedback coming to this. The other thing I want to mention is, you'll get a twofer if you go online, upload some parts, start quoting, check out SLA, check out the materials, take a look at some data sheets, and also you'll be instantly added to our XOM IQ sweepstakes. And Shilpa, do you have a little blurb on that?
Yeah. So the Einscan SP3D scanner that you see on your screen is actually the grand prize for the sweepstakes. We have 2 other prizes as well that are must-have tools for engineers. To enter, as Greg said, it's as easy as uploading a CAD file to our instant quoting platform, and you'll be automatically entered. So be sure to get quoting after this.
It's funny because we have a 3D scanner. So we have a higher end 3D scanner as first prize, and then second prize is another 3D scanner from the same line, a little bit lower end, but still a great scanner.
Correct.
And then the third prize is actually what I have in front of me right now, because I use it too, is a 3D Connection CAD mouse package, which I love, with the Space Mouse and the CAD mouse, and their wireless. So really cool stuff in the sweepstakes. But yeah, we have offer rules online as well. But the simple rule is, if you want to go online, create a quote, just make sure that you do sign up. You have a registered account. That's very important that you do that. And let's talk about, let's answer some questions here.
Got some great questions so far. The first one is, are there any materials that are medical grade or food safe that we offer?
You want to lean on Tommy? Yep.
Yeah, so I'd say that within our offering, there are materials out there that are medical grade and or maybe food safe. But keep in mind that even if you use that material, you have to have a manufacturing process as a whole to support that type of application. So I'd say that some of these materials that we do offer, if processed appropriately, may qualify for, you know, the USP Class 6 compliance, but we don't have the manufacturing line set up to be able to certify to that.
Yeah, the parts will be built with other parts, and those parts have different purposes. So oftentimes when I'm setting up a center that, for example, like ISO 1345 medical device center, I'm dedicating a machine, if not an entire room, to hit that compliance. And so right now, although we have access because we have a large network, right now we're really focusing on generic use parts and the materials that are surrounding that. That being said, there's been some materials that we have in mind that we may be able to offer in the future as well. We do have other materials that can hit some of those grades. So if it's not SLA, we do have, for example, our SLS nylon and our, you know, some DMLS materials like the stainless steels, for example, can get you closer to what you're looking for as well.
Right. And, you know, just further clarification on that is, again, the sticking point will be the manufacturing process, just because not only do you need to know the lot of material that was used for manufacturing, but anything that touches the parts down the line, you know, whether it's in SLS, you have to have lot traceability for the grit blast media that was used to manufacture the parts. And ultimately, we don't currently have that set up. We're very much more focused on the standard commercial offering.
Yeah. Hey, I see a question here. Do we need to design supports in the models we upload?
Nope.
The answer is no. So we take care. All we care about is your 3D CAD model, and you upload that. You upload what you want to receive, and select your process, your material, and any selections that you have. Sometimes, by the way, like if you select something like inserts, it'll ask for a drawing, and that's very helpful and necessary for us to know what you are looking for and where. But beyond that, we do everything. We do the support removal, we do the cleanup, and all you need to worry about is just getting your part in the mail. And so we really want to make that whole supply chain process very, very simple. And I truly mean we want to make that simple, whether it is a prototype or full spec production of your works. We wanted to have that same experience. You click and buy, order, and you get your parts in a box. And you know, we take care of the rest. Shilpa, what other questions we got here?
Someone has a question about printing speed and how SLA compares to 3D printing processes that use nozzles, especially when it comes to larger or smaller diameter of the nozzle.
Yeah, so what you're talking about, instead of thinking about what is depositing the material or curing the material, you want to look at kind of layer times. So often there's not the time to scan the part, and there's time to move between layers there. When you think about a nozzle deposit, it's like if you were drawing in a maze with a crayon and holding your crayon down, it takes that whatever time that surface area is to move that around. Lasers are much, much quicker. Usually, like a long layer is 13 seconds to scan down. Now, the larger the build area, the more that is. But when you look at processes like SLS, for example, SLA, and even DMLS, which is a little bit slower, you'll find that your time per layer is much, much shorter than that on FDM.
All right, next question we see here is please describe in some detail the post-build cleaning process.
Right. Okay. Yeah, I can take that one, Greg. So we kind of touched on this one earlier, but you know, basically the sequence of events that happens is the part is built on the machine. It raises up out of the vat. It's then taken to a solvent station and dunked in a vat of SLA solvent that will remove the liquid portion of the material, and then you kind of have the green SLA part
this left, and by green I mean uncured. And at that point, it's either going to go directly into a UV light oven while it's on the platform, or it's going to be removed from the support structures. Typically it's like a putty knife will be used to scrape everything off of the metal plate, and then you can just tear away the lattice port with your hands, or snip it away with some small scissors, or use an X-Acto knife. But then after all the supports are removed in that case, and you run it through one additional dunk to remove any scraps of material, then again it would go into the UV light oven and go for that final UV post cure. And once it comes out of the oven, then you're ready for sanding down the supported surfaces and whatever else is next.
So yeah, and to that point, I mean, we take care of all that. So what you may see, and this is similar with all our processes, like especially like if you look at DMLS and SLA, where the support material is the part material itself, you may see on the supported surface a small grid-like pattern, or you may see like a sandpaper mark, kind of like those parallel streaks, and that's just where we are cleaning up the support structure. If you choose a finish like matte, it's much more subdued. You may sometimes still see some grid structure on it, but it's much more uniform. If you do something with like standard finish, which is our default, you'll find that the vertical facing or I should say the unsupported surfaces tend to have a higher gloss look, and anything that's facing downward in the build would have support is going to have more of that matte look, and that's usually because of a hand touch up.
All right, we've got another question here. Are there material spec sheets for these materials to have properties of hardness, etc.?
Oh yeah. So if you go to our site, let me do. If you go to learn about our materials, so I have it on our FAQ, as well as if you click modify part, the link is right here as well. And even we have a spec sheet right here. We're trying to throw these spec sheets at you essentially. So if you choose between different materials, the spec sheet link will update. But if you click on the learn about our materials, we do have a list of different, like here's all these 3D printed plastics, and when you get down to stereolithography, you can see all our SLA materials, and you can look at the spec sheets here. And I did see something talking about max temp, so I'm just going to go and click on, I'm going to click on Soma's prototherm here, which is something that can have a post-thermal cure. So basically there's a pre-cure that are like basically the UV cure as Tommy was describing, and yeah, about 57 Celsius here. But if I go through a thermal post-cure, I can get that 110, 126 Celsius range of heat deflection, which is basically the amount of heat where your part stops performing like it should. So you can't find that information, and we do have a spec sheet for every single material that we offer.
All right. We are just about out of time for questions for today, but thank you all for joining. Greg and Tommy, any last words?
I'd say try it out. Even compare some costs. One of the beautiful things about our website is you can upload your 3D CAD file, and SLA, you can see the lead time, you can see the price as soon as you select it, and you can toggle between different materials and different processes just as easily. But I think one of the beautiful things about our site is that we offer all these manufacturing technologies in one place, in one platform, to help you make a better, more informed choice for your next project. And honestly, SLA is just a great tool in the toolbox, and there's so many things that you can do with it.
I concur.
Tommy concurs. All right, guys.
Yeah, I enjoyed it. Thanks, everyone.
Yeah, thank you all so much. I hope you have a great day, and we'll also have a recording of this webinar if you missed the beginning of it as well. But we certainly do appreciate everything that in your attendance as well.